Every time you make a choice, coffee or tea, left or right, do you ever wonder what happened to the path you didn't take? Most of us assume it's gone forever, it didn't happen. But there is an interpretation of quantum mechanics that says something astonishing. That path you didn't take? It happened, just in a different universe. And every time a quantum event happens, reality splits into parallel branches. An infinite number of yous are living out every possible outcome. This is the many worlds interpretation. It sounds like science fiction, but it emerges directly from the mathematics of quantum mechanics, without adding any extra assumptions. Welcome to Großdenken, everyone. Today we are going to explain exactly what many worlds says, how it works, what it predicts, and most importantly, what is scientifically proven versus what remains interpretation. Please support this channel by just subscribing. That would mean a great help. To understand many worlds, you first need to understand the problem it solves. Let's go back to the famous double-slit experiment. When you fire a single electron at two slits, it behaves like a wave. It goes through both slits simultaneously. It interferes with itself. And it lands on the detector in a probabilistic pattern. Here is the problem. Before you measure the electron's position, quantum mechanics describes it as a superposition, being in multiple places at once. The famous Schrödinger's cat thought experiment makes this absurd. A cat that is simultaneously alive and dead until you open the box. This is called the measurement problem. Quantum mechanics works perfectly to describe superpositions. But the moment you measure something, the moment you look, the superposition seems to collapse into a single outcome. The question is, why? What causes the collapse? The original Copenhagen interpretation said, don't ask. The measurement just does it. The act of observation collapses the wave function. But that has never been satisfying to many physicists. In 1957, a Princeton PhD student named Hugh Everett III proposed a radical answer to the measurement problem. His answer was, there is no collapse. Everett said, the wave function never collapses. It simply continues to evolve, smoothly and deterministically, according to the Schrödinger equation, always. So, what happens when you open Schrödinger's box? The superposition doesn't collapse into one cat. Instead, the observer, you, become entangled with the cat, you split. There is a version of you that sees a live cat, and a version of you that sees a dead cat. Both are equally real, both exist. They just can't see each other. This happens for every single quantum interaction. Every time a particle is in a superposition and interacts with its environment, the universe branches. All outcomes occur, each in its own separate branch of reality. In many worlds, there is only one wave function. It describes everything, and it doesn't collapse. It just keeps branching, forever. Let me state clearly what many worlds claims, according to its original formulation and modern versions. 1. The Schrödinger equation is always correct. It never needs modification. 2. There is no wave function collapse. Collapse is an illusion caused by the observer becoming entangled with the system. 3. All possible outcomes of quantum measurements actually occur. They occur in different branches of the universal wave function. 4. These branches do not interact. You cannot communicate with your other selves. 5. The probabilities we observe, like a 50% chance of spin-up and 50% chance of spin-down, come from the relative number of branches or the measure of branches. This is called the Born rule, and deriving it from many worlds is still an active area of research. Everett originally called it the relative state formulation. The term many worlds was coined later by Bryce DeWitt, who popularized it. Now let's be absolutely honest about what is scientifically established and what is not. Proven. Quantum mechanics works. The Schrödinger equation correctly predicts experimental outcomes with extraordinary precision. Superpositions are real. We have created superposition states with photons, electrons, even molecules the size of buckyballs. Proven. Entanglement is real. The act of measurement correlates the observer with the system. Proven. There is no experimental evidence of wavefunction collapse actually happening as a physical process. The equations without collapse work perfectly. Not proven. That the branches are physically real and exist as separate universes. Not proven. That the Born rule, the probability rule of quantum mechanics, emerges naturally from many worlds without adding extra assumptions. Not proven. That many worlds is the only interpretation consistent with the equations. Here is the critical fact. Today, all interpretations of quantum mechanics, Copenhagen, many worlds, pilot wave theory, objective collapse models, make exactly the same experimental predictions. There is no experiment that can distinguish many worlds from Copenhagen. By the strict definition of science, they are currently experimentally equivalent. So why do many leading physicists including Sean Carroll, David Deutsch, and the late Stephen Hawking prefer many worlds? Because it is simpler in one crucial way. It removes the collapse. Collapse is an extra rule added to quantum mechanics. Many worlds says, just the Schrödinger equation, nothing else. No special role for observers, no mysterious collapse mechanism. Stephen Hawking once said many worlds is trivially true. He meant if you accept the Schrödinger equation as complete, branching is an unavoidable consequence. The only alternative is to add something, a collapse rule that has never been observed. Many worlds also elegantly explains why we see only one outcome. You don't see the other branches because you are in one branch. The other you see the other outcomes. Subjectively, each version experiences a single, definite reality. Let me be clear about the limits. There is zero direct experimental evidence for other universes. The branches, if they exist, are permanently inaccessible. You cannot visit them. You cannot measure them. You cannot send a message to your other self. Many worlds is an interpretation. It is a way of understanding the mathematics. It is elegant, parsimonious, and taken seriously by many working physicists. But it is not proven fact. It might be true, it might not. Science does not yet know. What is proven is that quantum mechanics without collapse is mathematically consistent. Whether that implies real parallel universes is a question of philosophy as much as physics. So, every time you flip a coin or choose a path, did another you take the other road? Many worlds says yes. But for now, that remains one of the deepest open questions in physics. An interpretation that emerges from the math, fits all the data, but may forever live beyond experimental test. That is the beauty and frustration of quantum foundations. We have equations that work perfectly. But what they mean about reality, we are still arguing 70 years later. Thanks for watching. If you want more deep dives into the weirdest parts of physics, hit subscribe. And somewhere, in another branch, another version of you just did.